What's up? What's up? It's your man, Jimmy Chan. All right, so today we're talking about piecewise functions. So, a piecewise function is a function, a single function, that is defined by different functions, meaning different equations over different intervals. So, different equations over different intervals. So, this step here we're going to skip for now. We're going to jump into show you what does a piecewise function look like. One side of it, you're going to need to be able to graph or write the equations for those piecewise function. And then the other is going to be that you're going to have to graph the given functions. All right. So the first example here, we're given a graph, and what it wants us to do is write the functions and the interval that it goes through. Right. So this is one function right here, as you can see. Well, to let you know that this is one function right here. So if I was to do the vertical line test, there's not a single point where it crosses twice. And over here, if that's what you're thinking, that doesn't cross twice because if you look, this is an open circle while this is a closed circle. So along this line here of x equals 0, it only contacts one point and it doesn't touch that point right there. All right. So with that being said, let's take a look. So first, let's kind of break this up a little bit. So let's look at this right here. So what interval of the domain does this involve? Does this line involve? Well, this line involves anything from negative infinity to 0, right? So we're talking about the x values here to 0. So first of all, that first line here, let's actually do this. Let's make this blue. That means I have to make that blue as well. Uh-oh. There we go. Okay, so let's look at the blue line. The blue line involves when x is between negative infinity, and since this is a closed circle, it includes 0. Okay. All right. So that's the first thing we know. All right. So now let's look at the equation of this line. So to write an equation of a line, we need a point and we need a slope. In fact, better yet, with this one, we have a y-intercept. Right? So for the blue line, we know that the y-intercept, b, is equal to 0. Awesome. So let's look at the slope, right? The slope is rise over run. So if I was to go from one point to another, what did I do? So I had to go down 3, or I should do it this way. I had to go down 3 units, and then I went to the right 3 units, right? So my slope would be a negative 3 over 3, which gives me a negative 1. So now I can write the equation of this blue line, right? I got y equals mx plus b. So y is equal to negative 1x plus 0. So that means this is y is equal to negative x. All right, so that is my blue line. And that occurs in this interval. So this is going to be y equals negative x. Okay, so if we look at the red line also gives me a y-intercept. And that b looks atrocious. All right, and the b is equal to what? 1, 2, 3, 4, 5. Okay. Now, before I go to that, because the first thing we looked at was the interval before, right? So let's look at this interval. It goes from 0 to 1, 2, 3, 4, 5. So 0 to 5, but it doesn't include 0. You see that? So it goes from 0, doesn't include 0, and all the way to 5, but includes 5 because that is a closed circle here. All right, so here's the if. So now let's look at the equation of the line. We see that the y-intercept is at 5, And what's the slope here? Let's take a look. Oops. Right? So here I had to go down 2 and to the right 2. So my slope is -2 over 2, which is also equal to -1. So now I can write my red line here. So y is equal to -1x plus 5. So y is equal to -x plus 5. So there goes my red line. That apparently can't force it to create a box. There we go. All right. So there's my red line. There we go. So that would be y is equal to -x plus 5. So notice that these are going on to different intervals here, right? So from -infinity to 0, so from -infinity all the way to 0, we have the blue, and then from 0 to the 5, we have everything that's red. So if you notice that everything here is blue and everything here is red, which is the same thing here. So how would you see this? You would see this as with a squiggly bracket, and then it's going to say f of x is equal to that. All right, let's make it a little prettier. So that is what you would see as the answer to that graph. Okay, doke. All right, so what other examples would we see? Well, you may be given, so this one you're given a graph, you gotta give the function and the interval that it spans through. So the other example is, okay, well, you're given this, and you gotta come up with a graph, so exactly backwards. So let's take a look at the second example, which says, okay, so I have this so-called piecewise function, and I need to graph it. Well, to graph it, what I want to do, again, I'm going to go ahead and take that, make it red, take this one, make it blue, and take this one, and let's make it purple. Okay, there we go. All right, so let's go ahead and graph it. Now, this is only going to from -4 to 0, but not including 0. So let's do this. So let's go ahead and make a quick table. Okay, these are going to be my x values, right? So I'm going from -4 to 0. Okay, and this is going to be during the point of the x plus 2, right? Or should I do it this way? F of x is equal to x plus 2. So if I plug in -4 in here, what do I get? I get a -2 because -4 plus 2 is -2. And if I plug a 0 in here, 0 plus 2 is equal to 2. But remember, this is going to be an open circle. Okay? All right. So that part's done. So now let's take a look at the blue. The blue says that f of x is equal to x squared. And we're going to go from 0 to 2. And we're going to include both of them. Okay? So I guess I could do it this way too, just so you guys can see. This would be a closed circle. And then for the blue, if I put 0, square it, it's still going to be 0. And if I put 2 in for x, I'll get 2 squared, which is equal to 4. And both of these would be closed circles. All right. All right, that part's done. Let's take a look. Now the next one says that f of x is equal to -x plus 5. All right, and that is going anything greater than 2. So when it says that and doesn't really have an endpoint, I usually like to plot at least 2 points. if not 3. So let's say I'm going to go 2, because I know that's going to be an open circle. Let's go 3, and let's go 4, just because. Okay, so let's go ahead and plug in the 2 in for x, the 3 in for x, and the 4 in for x, and see what we get. When we plug the 2 in, it'll be -2 plus 5. 3 in there will be -3 plus 5. 4 in there, -4 plus 5, right? So this is going to be an open circle at 2. So it's going to be an open circle at 2. Now I can't, the 3 and the 4 is just going to be line going through it. So, okay, so let's go ahead and draw a graph. I don't see a lot of negatives here, so I would just draw it right here. There's my x. There's my y. All right, so let's take a look. For the red, x is -4. Let me see, 2, 4. And it's going to be -2, so it's going to be right here. And it's going to be a closed circle. And it's going to 0, 2, 0, 2. Oh, that's a really big circle there. Really big open circle, okay? So I'm going to draw the line here to here. Oopsies, went a little too far in. Oh no. There we go. All right, so from to the 0, all right, open circle. Now next is going to be the blue, and at 0, it's 0. So this is going to be a closed circle here. It's going to 2, 4, so 2, 4. Also a closed circle here, and I connect those 2 dots. Oh, actually, I don't connect those 2 dots because this is a quadratic, right? So really, it's curvy. So it kind of looks a little like this. Right? And the reason why is because, so remember, I did not graph 1. If I did 1 squared, where would it be? It'd be 1, 1. So that's why it has to be somewhat curved, okay? So be careful with that. Know what is a straight line and know what is a quadratic, all right? Remember, straight lines or diagonal lines have an x and a y in the equation, where quadratics has an x squared and a y, all right? All right, so purple. So at 2 is going to be 3. Oh boy. I picked a winner. So this is going to be an open circle. And then it's going to go through 3, 2. So I'm drawing this line through 3, 2 and 4, 1. Actually, I should draw it this way because it goes, I believe it goes forever, yep. So it goes through 3, 2, and 4, 1. So it's going to look something like that. So that means I didn't really need this to look anything like this, huh? I could have just done it to here, bring it down so it looks a little bit better, to here. And there we go. Oopsies. Whoopsies. All right. So again, if you look from -4 to 0, from -4 to 0 is the red, from 0 to 2 is the blue, and from 2 on is purple. Okay, so this would be considered a piecewise function. Now, based on the steps I gave you here, what is it talking about? So it says, step to determine which function to use for a given x. Determine which interval does the given x lie in, which function does that interval involve, plug the x into that function. Okay, so let's say, for example, these are the functions that were given to me as a problem, right? So, and it says, hey, I want you to find f of 3, right? So if that's the case, question is, well, number one, what we do know is that this 3 is my x value, right? And what this is trying to say, this whole thing, however, is really looking for my y value. Okay, so again, so the difference between the two, just so you guys know, is that the x is a 3 and I'm looking for my y value. So in here, where does this 3 lie? Does it lie between 0 and 5 or negative infinity to 0? It lies right in here, doesn't it? So if it lies in here between 0 and 5, that means this is the equation I deal with. So let's go ahead and do that. So f of 3 would equal to negative 3 plus 5. So that would be negative 3 plus 5. So that's going to equal to a 2. Okay, so my y value there is 2. And don't forget that really I have a point right here. And that point is going to be 3, 2. So when my x value is 3, my y value is 2. All right, so let's say I'm looking for f of negative 3, right? So I know that this is my x value, negative 3. So where does it lie? Does it lie between 0 and 5 or negative infinity to 0? Well, that would lie here between negative infinity and 0. So this is the equation I would use. So that would say this is equal to negative 3. So that's going to give me a positive 3, which also gives me a point. Of negative 3, 3. All right. So, and you guys can look at it on the graph as well. So if you look on the graph, when the x value is 3, 1, 2, 3, I'm in all sorts of the red zone, right? So 1, 2, 3, what's my y value? It is a 2. So there you go, 2. When I'm negative 3, 1, 2, 3, I'm clearly in the blue zone. So if I go up to the graph, what's my y value there? It's a 3, so that's why it says 3. All right. So what about here? What if we're given a function to use? So let's say it wants f of 2, right? So if that's the case, let's take a look at 2. Does 2 lie here? Is 2 greater than 2? No. Does 2 lie between 0 and 2? Yes, because 2 is included here, so that means the blue equation would be what I want. So from there, I'll have, that's going to equal to the 2 squared, which is equal to 4, which gives me the point 2, 4. Okay? So if you look at it, let's look at the point 2, 4. Where's the point 2, 4? 2, 4 is right there, right? Right exactly that endpoint, right? So what if I said find f of negative 2? Well, let's take a look. Where does negative 2 lie? Does it lie? Is negative 2 greater than 2? No. Is negative 2 between 0 and 2? No. Is negative 2 between negative 4 and 0? Yes. So that means I must be using the red equation. So that's going to equal to negative 2 plus 2, which is equal to 0, which gives me the point of negative 2, 0. All right. Well, I hope that helps. If there's any questions, please let me know. See ya. Bye.